This will be a relatively short video. I want to mention about something called the Doppler Effect. We'll probably get into it a little bit more when we talk about sound waves, but I wanted to introduce it to you today. So let's think of a bug, and it's sitting here by itself and it's producing disturbances in the water. It's swimming, I guess. And when it does that, the waves are working out in all directions evenly, right? Now as the bug starts to swim, so it's going to start swimming in this direction. As the bug starts to swim in this direction, we see another disturbance, and what happens is the waves towards the bug get closer together. The waves going away from the bug get further apart. So you could say, as the bug goes forward, the waves in front of the bug increase their frequency, and the waves going away decrease their frequency. Okay, we're not changing speed or anything. Okay, wavelengths are changing with the frequency to make that happen. We're not changing mediums. All we do is have the waves increasing or decreasing frequency because the object making the waves is moving. So the Doppler effect is when a moving source of waves and when there is an apparent shift in frequency for observers towards where the source is approaching, and a downward shift in frequencies when they're away from the source. So if a police car is coming towards you, it has a higher frequency. If it's going away from you, it has a lower frequency. That's why the sound is different when police cars come towards you and away from you. And again, we'll talk about that when we talk about sound waves. Now, what effects does this have in other sciences? Astronomy is the big one. So we worry about the Doppler effect because as we look into the sky, we see light, and this light can be different colors. And the colors are caused by the frequency and wavelength of the light. So the waves we see and the frequency they have kind of give us information about where they are and where they're going. Now, the reason the Big Bang Theory is believed to be true and that the universe is expanding is because we see electromagnetic waves, proving to us the frequency as it's moving away from us, the frequency is getting greater. So as frequency is increasing, or decreasing, sorry, decreasing, then what we're seeing is the galaxies are going farther away. So we expect a downward shift in frequency. Now, when we look at light, and if you remember the Roy G. Biv, right? We expect to see a red shift from these galaxies and stars as they move away from the Earth. So as things move away from the Earth, they should be showing red. Now, if there's what we call a blue shift, so higher up in the visible light spectrum, what we see is the radiation is that the rotation is coming towards the Earth, or moving towards the Earth. So Big Bang Theory says everything was here and the universe is constantly expanding. We should see a lot of red shift from galaxies as they expand out. If we ever looked into the sky and saw a bunch of blue, that would mean these objects are coming back towards us, which probably is not the best thing to happen.